Arg mateys, today we will, sorry that sounds so like Mr. Russian. We're doing logarithms, woo! That's it.
Alright, so I'll probably say this a million times before we wrap this chapter up, but it's going to help you remember. Logarithms always are equal to exponents. They always equal to exponents. The log expression, yes. Alright. Logs are very useful for us in that they help us to solve exponential equations because logarithmic equations and exponential equations are inverses of each other. Okay? Remember we talked about another set of inverses before? Do y'all remember what they were?
Square rooting and
Quadratics and square roots. Those, think about those graphs, right? So now we're talking about the inverse of the exponential. So think about the exponential growth and decay graphs that we did. This will be that on its side. Y'all ready?
no.
All right, let's start algebraically first. Ready or not, here we go. If I have b to the x equals a, I can rewrite this using logs. This is what we call exponential form. Exponential form. I can write this in logarithmic form. Like this. Log base, and I'm going to write it as a subscript, base b of a, and logs always equal, that's where y'all say exponents. Okay? And so this, everybody gets confused because it looks so crazy, but this is essentially the same thing as saying 1 plus 5 is 6, right? 2 times 3 is 6. Different ways of saying the same thing, right? 1 plus 5 and 2 times 3 are still the same thing. This is the same thing, it's just writing it another way. Your key as you get stuck through logarithms is going to be your ability to change forms fluidly from one to the other. So let's practice a few and see what happens.
Where is log on the calculator?
Okay, so the log on your calculator is only a base of 10, and we will talk about that later. You cannot use that just yet until I teach you how to do it. Yes, yes. This is used for solving for the exponent for sure, yeah. Not today, but yes. It's, huh? Y'all are jumping. I literally like put the definition up, and y'all like, how are we gonna? And what are we gonna? And how are we gonna? And what? All right now, I want us to focus on changing forms from one to the other. Okay. Don't worry about solving or anything like that. So, for example, do you all agree with this statement?
Yes.
How would you write that in logarithmic form?
2 log equals 8.
Log base 2 of 8, because logs always equal exponents. Okay?
It's going to get worse, Ava.
No, don't assume it will.
You know what assuming does?
That's right.
What does it do now?
Nope.
Not on video.
Can you whisper in my ear?
No, we're not whispering in each other's ears. Log of base 2 of 25 equals 2.
5 to the second. Yes, sir.
This is literally just being able to rearrange and rewrite. I'm hesitant to say this. Does that make sense?
No.
No, for real.
So,
Y'all stop.
there's no, like, working out we have to do with this?
Not in changing forms, not yet. Shh.
And I'm good.
All right, guys. I'm gonna hit record again. All right. Tell me this. Let's do some evaluating. The changing forms. All right. What do you think this equals?
Whatever, yeah.
Why does it equal 3? 4 to the third power is 64. Bless you.
Just to give, 3 to the fourth power is 81.
Yeah.
I thought I could figure that out last night.
Don't answer this too quickly. You know it, Indias? It's log base 4 of 2. So the 2 is written on the same level as the log. The 4 is written as a subscript.
Hold on. Let me calculate it.
How's it 1/2?
Okay, so let's think about it.
It gives us 2 points.
It is.
4 to the what power gives you 2? A half, because a half exponent is the same thing as what? A square root.
Wait, so to figure this out, can you just square root 2?
No.
You like, if you root it by the number of.
You're trying to find the exponent. How about this one?
Wait, to find this, can you root the big number by this?
Not always.
It's gonna be a negative.
Oh, you got it. How do you know?
Because my homework last night.
I did this one for Mary.
Yeah, it's -4.
It's -4. You're exactly right. Because 3 to the -4 is 1/81. Y'all are too good at this. Okay, so a square, anytime you see a square root is the same thing as an exponent of 1/2 because there's an imaginary 2 out here. Because your calculator's only doing a base 10.
Somebody tell me to see that fly now.
If I kill it and forget, I put that
Shh. Let me show you a couple of or actually let me let you reason through these real quick. What if I had log base 5 of 1? Yeah.
It'd be 0.
Why?
Because 5 is 0 power is 1.
That's exactly right. That's a property that you will find very handy. Log with any base that you put here of 1 is always going to be 0. Because the only way to get 1 is if you raise it to the 0 power.
So I know how to use it.
Okay? So that's going to be a property that will show up, and I feel like we'll get to that tomorrow. Here's another one.
If the base is 1, does that mean it's going to be
If the base is 1,
Yes.
1 to the what power gives you...
That would just be
Does it have a negative?
You wouldn't... You can't do anything that you don't have a log base of 1. You wouldn't, because there's nothing, it's always going to equal 1. You see what I'm saying?
What if you
What if it
had.
was like negative?
It would always.
Y'all stop.
We want to ignore the.
Do it. Loop stroke.
Y'all stop. Come on. What do you think this equals?
It would equal 5. It would equal. Because it's like real.
Think about this. If you think about it, it makes sense. 3 to the what power gives you 3 to the 5th.
That's easier than
What?
3, 5 was 3.
I mean, this could give you an answer.
My hardest thing is like setting it up
35
into the
and
form.
35.
3 to the what gives you 3 to the 5th. 3 to the 5th gives you 7.
It's just 7.
It's just 7. Could you generalize this a little bit, guys? I feel like I am fighting to teach y'all this. Could you generalize this a little bit more for any situation that looks this way?
Oh, the exponent will always be the exponent.
If the bases here are the same, then whatever this exponent is what your answer is going to be. Essentially, that's what you're doing whenever you evaluate the logs anyway and you change forms, huh? It is easy. It
Wait,
is
what
easy.
if the bases are different?
Then it wouldn't work this way. But sometimes you can manipulate it to work this way. Like, for instance, the ones y'all just did. So we did, let's say log base 3 again. Mary, this one's for you. Base 3 of 81. We know that that's 4, but I could also change 81 and write it as log base 3 of 3 to the 4th. It's a little, but if you recognize it, if it just happens to already be written a certain way.
The base at the bottom is different. Like, is that-
Yeah?
Is this exponent to be absolutely zero?
Yes.
I mean, you need to be able to recognize that property, but yes, no, -2. I just need to flip the 4. I need it to flip over and square. All right, let's graph.
This is a fraction.
1/4, right, to the what power would give you 16. So to flip it, I'd know it need to be negative, right? The negative, well, you're not multiplying, you're raising it to a power. So the negative will flip it over and make it 4. So really you're saying 4 to the what power would give you 16. That's 2, right? But I need to make it negative so it'll flip that 4 over. All the negative's doing is flipping.
You said we're graphing?
Huh?
You said we're graphing?
Yeah, we're in graph. Just a second. The hardest part about this is deciding what numbers to plug in to use. Okay? Here's what I'm gonna do. I'm gonna show you, like I said, the shortcut. Instead of us having to go through base b of x minus h plus k. You may or may not have all these numbers in your equation. Okay? If they're not there, h and k are 0 if they're not there. A would be 1 if it's not there. All right? Remember I told you this was the inverse of an exponential? So it's like an exponential on its side. So instead of a horizontal asymptote, it's going to be vertical, but it's literally going to look just like the growth and decay just on its side.
And so would these things be for like spaceship? Sorry. go on.
Actually, logarithms, the most realistic application I can think of off the top of my head, the Richter scale for earthquakes is
Really?
based on a logarithmic scale.
That's earthquake.
Wait, which one's
You
growth?
taking the
Okay.
earthquake scale?
Doesn't matter.
Magnified?
You don't, no, they're not, but you don't have to worry about,
I mean, if it's
we're not
like-
gonna classify them or anything.
So earthquakes are
right.
exponential?
The scale to measure them is a logarithmic scale. You know, the Richter scale that goes from whatever to whatever. Here's what you have to remember with logarithms. Everything about logarithms is opposite exponents, okay? So instead of a horizontal asymptote, I'm talking about a vertical asymptote. Instead of it being the k on the end, my vertical asymptote is going to be my h. But it's opposite sign. Vertical asymptote. Wait,
I thought the thing was
the K is the asymptote in growth and decay. But because this is logs and everything's backwards, my H is going to be my asymptote. And from there, we're going to pick two easy points to
You
use.
said opposite sign, right?
You say opposite
Yeah, yeah.
You start
opposite
out
sign.
negative, so it would be.
Correct, correct. All right, so I think the easiest way to do this is to show you, because the hardest part about this, again, is picking your point. So let me pick one that's got some transformations in it. And let's do this. Let's see. No, we don't.
Falling forward.
This is Wednesday.
You sure?
I'm positive.
Are you like 1,000%?
Oh, I have a, math
See what time we get out.
that's relative to this subject.
All right, look at this one. Positive 3 is my asymptote, okay? That's about all the information you're going to glean from your equation.
Is that 1/4?
That is 1/4. All right, now here's what you need to think about. I need to pick points that are going to be easy to evaluate as I plug in. And right now I'm looking at a base of 1/4, right? So I need these to be powers of 4. The easiest thing to do is to make that first thing, remember that property where we said log base b of 1 is always equal to 0? The easiest thing to do is make the parentheses equal 1 as your first easy point because of that. So if I want this inside parentheses to equal 1, then I should probably pick 4. Right? And if x is 4, well, that means y is 1/2 times the log base 1/4 of 1, which is 0. So this whole thing is 0. Because any base of 1 is 0. Because 1/4 to the what power gives you 1? 0. Do what? I plugged in 4 for x. So 4 minus 3 would be 1. This is 0, and anything times 0 is just 0. It was just it multiplied there. It's part of the original equation. What's 1/2 times 0? 0.
It's gonna be the third.
All right, the other thing that I would do is I would make it equal, I would make those inside parentheses equal to the base or the flip of the base, right?
It's 7.
Because if they're the same, what does that equal? B to the what power is B?
B.
1, right? There's an imaginary 1 here. If the bases would be the same, right? 4 to the what power is 4? 1, right? Does that make sense to y'all? Look at me like I'm crazy. So if I can make this inside become 4, that's a good point, right? What would I need to plug in order to make that 4? 7. If I plug in 7, I get 1/2 log base 1/4 of 4 7 minus 3 here. I picked 7 because I wanted the inside to be 4. 1/4 to the what power is 4? Close. -1. Remember, I want it to be the same as the base or the flip, because the flip would just be -1, right?
Can you say that again?
All right. 1/4 to the what power gives you 4? -1. Right? So this gives me -1/2. 4, 5, 6, 7, -1/2. Which one in the begin, it's still the same 1/2 here in the beginning of the equation. I'm just plugging in is what I'm doing to find a point. 1/2 what? Yes. Exactly, everything's backwards here. Yep, yep. The domain is the one this time. Remember before the domain was negative infinity, infinity, and the range was restricted? Now it's flipped because they're inverses. What was x is now y, and what was y is now x. So my domain here
3 to infinity.
is from 3 to infinity, and my range is not restricted. I know we're pushed for time, but I want to do one more with you because I feel like I'm
This is
just...
gonna be a very struggle.
I don't think, this is as hard as it gets. I did the hardest one first, and maybe I should have done an easier example first, but I wanted to make sure I got through the harder one because it had the fraction in it and it had the multiple parts
So
in
just
it.
remember, in the parentheses, you want it to be the same.
You want it to be 1, and then you want it to be the same. It'll never be on the left side because you would have an error. You can't take anything, any base that's not negative, raise it to some power and make it negative. It just doesn't work. So that's why they're not over there. All right, let's do one more. Uno más, uno más. Let's do, let me grab one from your homework.
Wait, you can't take a base that's negative and make it something not negative? Like, what if you have -1?
You can't take a positive and make it negative.
Oh.
Like you can't take the number 5 and there's not a power you can raise it to make that become negative. You see what I'm
I
saying?
thought you said you couldn't make it.
I might have said it backwards. But that's what I meant. I'm sorry. Let's do. Ooh, what is wrong? I'm just writing and it's not even. Let's do log base 3 of x. We'll make it easy. I'm missing everything, right? There's an invisible one. So A is 1, H is 0, and K is 0. So that means my asymptote.
Is it 0?
This is going to look like a parent function for me because there are no transformations here. There's no transformations. There's nothing shrinking, stretching, shifting.
Just, it's part of your graph.
Well, so you can, but the problem is they're going to be hard to graph. So like, this is asymptote. If I let x be, remember I want the base to be 1 first, or I want that a to be 1 first, not the a, but the big number here. Okay, so that whenever I plug it in, the log portion of it will be 0. And then if I can force the bases to be the same, and maybe not even the same, but the flip in the same, right? Because that's either going to be 1 or -1. So pick 3. Because anything, any base at all, if this number is 1, it equals 0. And so now y equals log base 3 of 3, which is what I wanted because when those are the same, I get 1 because this exponent here is 1. A little bit easier than the last one.
Good morning, CHS. It's time for the morning announcements.
Domain
Please
is
stand for the
0
Pledge
to
of Allegiance.
infinity on this one.
Quiet.